A good day to everyone. I am Rishban Parithiban, 2180077. Today, I would like to present about my thesis, which is investigation of mechanical properties of composite sand brick with shredded waste tire. Municipal solid waste management has emerged as a major issue in global development plans, particularly in rapidly growing cities. Malaysia is undergoing fast industrialization and urbanization, which is having a negative impact on the environment due to an increase in solid waste. Trash tires are a significant source of solid waste. There is a lot of interest in recycling this non-hazardous solid waste to reduce the negative effects and to promote sustainable development. Waste tire can shred it into small pieces and reuse in sand brick as replacement of aggregate. In the construction industry, the use of waste tire in sand brick has enormous potential. For both environmental and economic considerations, recycling tires in the application indicated above is an appropriate form of disposal. The objective of this thesis are to determine the optimum percentage of shredded waste tire as replacement of aggregate in sand brick, to investigate the mechanical properties of composite sand brick with shredded waste tire. Finally, to examine the compressive strength, impact load, and water absorption of composite sand brick added with shredded waste tire. Now, let's see the problem statement for this thesis. The increasing number of vehicles has a direct influence on the amount of solid waste created. Tires, due to their weather resistant and non-biodegradability, require a long time to degrade in the natural environment. Tire burning is the most often used technique of disposing since it is the simplest and least expensive option. Burning waste tires causes fire and produce harmful compounds that pollute the environment significantly. The use of waste tire in sand brick can help with environmental pollution prevention and sustainable waste resource. Now let's see the methodology. First of all, it is started with the literature review, then followed by sample preparation. 3%, 4% and 5% of shredded waste tire as replacement of aggregate were used as sample in this thesis. For the laboratory experiment, compressive strength test, water absorption test, impact load test were conducted. Then, result from the laboratory test was collected. From the result collection, analyses were made. Finally, conclusion and discussion are done. Now, let's see the results. Graph 1 shows the compressive strength test data. From the result of this test, it can be concluded that mixture 1, which has the highest compressive strength, which has an average value of 19.53. Control sample as recorded as the lowest compressive strength, which has an average value of 7.53. The result implied that bricks with more percentage of shredded waste tire generally cannot withstand to load, and the increase of shredded waste tire gradually decrease the compressive strength of a composite brick. Graph 2 shows water absorption test data. The result shows that mixture 1 has the lowest water absorption percentage, which has an average percentage of 6.34, whereby mixture 3 is recorded as the highest water absorption percentage, which has an average percentage of 9.87. A brick with low water absorption capacity better resists to volume changes, which prevents possible cracking of the bricks and structural damage in buildings. The result shows that the increase of shredded waste tire increased the water absorption capacity. Graph 3 shows that the impact load test data. According to the data, control sample break entirely on the first attempt, whereby mixture 1 contains 3% of shredded waste tire has an average of 7 repetitions. This shows that mixture 1 has a good absorption of impact energy. It also can be said that the increasing percentage of shredded waste tire in brick will decrease the impact resistance. As a conclusion, in a nutshell, The goal of research is successfully achieved. Laboratory experiment test shows that mixture 1, which contains 3% of shredded waste tire, is the optimal mixture in sand brick. From this proposed method, the use of shredded waste tire in sand brick will eventually increase the strength and the durability of a brick. Laboratory tests prove that the use of waste tire in sand brick has enormous potential in the construction industry. As consequences, the use of shredded waste tire in the creation of composite brick will reduce the number of waste tire and also help with environmental pollution prevention. Thank you.